Research in English language teaching is moving away from basic computer assistance. The discipline is actively integrating computational intelligence into the classroom. To see the standard required to publish in this space, look at the journal Teaching English with Technology, or TEwT. It operates at the top of the field, maintaining a Scopus Q1 ranking in the 98th percentile and holding a 2025 CiteScore of 10.4. Journals operating at this level apply intense editorial scrutiny to new submissions. They actively filter out superficial technology evaluations. If you submit a survey measuring how students feel about using ChatGPT, the manuscript will be desk rejected. The editorial board requires objective data, not a catalog of subjective user feelings. Securing a Q1 publication requires proving empirical linguistic development. The research must demonstrate exactly how a technology intervention improves the mechanics of student writing. There is an inherent problem with deploying generative AI in an academic writing environment. When an external language model perfectly rewrites a student's technical paper, the tool bypasses the student's cognitive process entirely. The output looks exceptional, but the student hasn't acquired any new vocabulary or syntax. It creates a short-term illusion of high performance without actual language acquisition. To solve this, your research design must isolate a human-AI collaboration model. The AI must be constrained to act as a pedagogical mediator rather than a ghostwriter. Proving genuine writing improvement requires engineering a structured, multi-stage feedback loop and then measuring the results using specific, objective linguistic variables. Building a high-tier research architecture starts with selecting an appropriate theoretical framework. Many researchers default to the technology acceptance model, mapping whether students find a tool easy to use. That model cannot measure actual writing improvement. Anchoring the study in sociocultural theory and academic literacies defines AI as a mediating tool. From this foundation, we establish the independent variable, feedback type. We then measure objective dependent variables, lexical diversity, cohesion, and technical terminology, while tracking baseline proficiency as a moderator. Grounding these objective variables in sociocultural theory elevates the study. It moves past a shallow tool evaluation and becomes a rigorous pedagogical investigation. With the variable set, we construct the intervention itself, requiring absolute standardization of the prompt engineering. You must force the large language model to act as a diagnostic tool. The prompt instructions shown here command the AI to identify organizational and lexical issues while explicitly forbidding it from rewriting the text. Stage 1 of the human-AI collaboration loop begins. AI provides preliminary, syntax-level feedback on the student's draft. In Stage 2, learner evaluation, the student processes this data, manually deciding whether to appropriate or reject each specific change. This exact moment of critical evaluation is where the cognitive work happens. The friction of deciding why a suggestion is correct drives true metacognition. That brings us to Stage 3, teacher guidance. Because the AI handled mechanical errors, instructors focus entirely on rhetorical critique. The student then synthesizes both the AI corrections and human feedback to produce a comprehensive final revision. This three-stage loop successfully restricts the AI to a syntactic scaffold, preserving the human instructor's role in high-level rhetorical development. To empirically validate this intervention, the study requires a strict, multi-arm quasi-experimental design. Look at this trial design. We take a recommended sample size of 120 students and divide them into 3 distinct comparative groups. Group A receives traditional teacher feedback only, Group B receives AI feedback only, Group C receives both. Before the intervention begins, all students complete a pretest to establish a concrete baseline. The intervention then runs simultaneously across all groups for 8 to 12 weeks, generating continuous text data, followed immediately by a short-term post-test. Then we execute the most critical measurement phase, the delayed post-test. Short-term memorization fades over time. The delayed post-test is the only metric proving actual long-term retention of technical vocabulary and complex syntax. Mapping these 3 distinct pathways over an extended timeline identifies the specific impact of human-AI collaboration on lasting writing proficiency. This 3-armed trial generates a massive amount of layered data across multiple timeframes. Basic t-tests are inadequate here. They cannot track complex, multivariable linguistic development happening simultaneously across different groups. You need sophisticated statistical tools to map longitudinal data of this scale. This requires linear mixed effects modeling. This statistical model links the student's interaction with the AI directly to the quality of their final written output. It allows you to isolate feedback uptake as a critical mediating variable. This measures exactly which AI suggestions the student accepted and which they rejected. Tracking this uptake statistically proves whether a student actively evaluated the language mechanics or simply pasted the AI's response without reading it. Applying rigorous statistical modeling to feedback uptake provides verifiable data meeting the threshold for high-tier publication. The final step is packaging this rigorous methodology to survive a journal's double-blind peer review. You must satisfy strict ethical requirements. The manuscript must explicitly detail how student data is protected when texts are uploaded to external commercial language models. Submissions also require fully anonymized manuscripts, transparent documentation of all AI prompts, and explicit reporting of effect phases. Executing this exact methodology positions your research for a 0 APC publication in a 98th percentile academic journal. AI will not replace the language instructor, but mastering the human-AI collaboration model is the foundational framework for leading modern TESOL research.